We first flew out to Loiyangalani in Marsabit County some 5 months ago and drove a further 120 kilometers to Sirima, a dry, desolate corner of Kenya that seemed as inhospitable as it was inhabitable. Nothing, it seemed at first, could ever come out of this. How wrong we were. Because right here in the middle of nowhere in Kenya, the largest wind farm in all of Africa had been constructed in what has come to be the biggest private sector deal in the country's history. Some 70 billion shillings worth, more than twice what it cost to build the Thika superhighway. It is called the Turkana Wind Power. 365 powerful wind turbines spread across 40,000 acres in one of the windiest counties in the country. The project had been completed sometime last year, but was missing one key component: a transmission line to evacuate the wind power from here in Sirima all the way to Suswa in Narok County, some 432 kilometers and 6 counties away. The Kenya Electricity Transmission Company, KETRACO, had contracted a Spanish company to build the T-line, as it's known in the business. A few kilometers into the project, the Spanish company declared bankruptcy, stalling things temporarily. The Kenyan government stepped in and awarded a new contract to a Chinese company. That was 4 months ago. This week, we flew back to Sirima to see for ourselves whether KETRACO has fulfilled its promise of connecting Turkana wind power to the national grid. On the ground in Sirima, we are met by a group of engineers led by Joseph Saipimei. He says the T-line has been connected and KETRACO is already conducting tests to ensure the wind power gets to its destination.
So the line is complete. We have all the towers up. We have both circuits have been done and they have been energized. So whatever the conductors you're seeing up there, both of them are energized.
Yeah. And tell me about this connection. You said there was 2 lines here.
Yes.
Talk to me about that.
It is just one line, which is a double circuit. So
what does that mean, double circuit?
A double circuit means a line that has 2 circuits, one on the left, the other one on the right. And the double circuit is used, you can use power to evacuate using one circuit. If you have any maintenance that you want to do or anything that you have to do on the line, you have the second circuit to help you. Yeah. So one is for redundancy.
Okay, so right now it's sending out 200 megawatts of electricity.
Yes.
So probably some of the electricity we have in our homes is already coming from Turkana wind power.
Yes. So when this power comes to Suswa, it is now distributed to consumers in Nairobi, in Mombasa, in all those towns that Suswa is supplying.
Saipimei takes us around.
We have now gone against the direction of the wind.
Okay, it's less.
So that all the time.
About it, Safia. We start there and we come this way. So Joseph, on that side, Lake Turkana wind power.
Yes.
On this side, KETRACO. Okay, what is that over there and how does it get over this side?
Over there, as you can see, those are turbines. The turbines are the ones that are rotated by the wind to generate power. So the power that is being generated by the turbines is evacuated through the small lines, the 33 kV lines that you can see running all over. When they come to the substation, they are fed to these transformers from the primary side and evacuated through the secondary side to our side. So you can see the big equipments there are transformers which are in single phase. There are 9 of them. So as you can see, all those equipments are there, belong to Lake Turkana. From this fence going that way, they belong to KETRACO. So just as a recap of what is inside the substation, all these are equipments that are assisting in protection, in knowing what exactly are you doing here in terms of voltages, in terms of currents. So that is a current transformer, and that one is a voltage transformer. So a current transformer is just a transformer that helps you record the currents that are flowing through the circuit, and the voltage transformer is taking care of the voltage across the circuit.
Okay, and as we walk, so then as the current comes in here, right?
Yes.
And you're monitoring it in a central room.
Yes. So it comes from there and comes into this bus. This is called a bus bar. There's three lines that you are running across.
Yes.
That is called a bus bar. So this is bus. There are two bus bars for this substation. So this is bus bar 2. The other one on the far end is bus bar 1. So when you have all the power that is being evacuated through those transformers, collected in this bus bar and in that bus bar, that power is now evacuated through the lines. So the bus bar is where you collect all the power to it, then evacuate that power through the double circuit that you are seeing, that we've already seen on the other side.
And you've been this is what you're monitoring, 200 megawatts going all the way to Suswa.
Yes.
So far.
So far, see there.
And when the wind is so inconsistent, right?
Yes.
Sometimes in the morning there's a lot of wind.
Yes.
At lunchtime, not too much.
Yes.
Evening, maybe some more wind.
Yes.
How do you consolidate all that into, one big wind power?
As I've already told you, the generation is within the turbines. So normally, what happens, if the wind speed goes down, definitely the power generated goes down. So it will now depend with the wind speed. Then when all that power is collected there, it is taken to this bus, which is now evacuated. Yeah. So if the amount generated is directly proportional to the speed of wind.
And you've tested them, you've retested, they're all 100%?
100%. We have retested them when we were doing the actual work, the actual construction. We have also retested them when we have energized. So we have done what is called cold commissioning and hot commissioning. That is complete. We are very ready.
Showing off the state-of-the-art control room built by French engineers from Siemens and now being run and maintained by Kenyan engineers.
So this is a control panel for the C01. C01 is the line 1. You saw the line 1?
Yes.
That is C01. So all the equipments that are there, you can feel their status here. All of them, you can see the red one is showing that they are okay, they are functioning, and they are closed. Yes, because we are doing the evacuation at the moment.
Correct. As we speak, there's power heading to Suswa. Engineer Jose Mwehaki has been here in Sirima from day one, where there was nothing but rocks and bush and a lot of wind. Seeing this project to its completion is something even he thought was an impossible dream.
When this project started, it was a plain field, and when the contractor moved to ground, the first step was to get the levels right, set out the foundations, and after that, start the erection of the structures that we are seeing. And once the structures were up, by the time they were up, the equipment that were brought from abroad were also available at site, and they were also erected. And then after erection, the equipment were ready to be tested and commissioned. That is what we used to call cold commissioning before we got the power, backfeeding the power from the grid to have the equipment hot tested and hot commissioned.
So engineer, at the end of the day, this transmission line evacuating the electricity, what does it mean for the country? Explain to us, what does it mean?
First of all, this transmission line is capable of transmitting nearly 1,200 megawatts. What we are generating here with this wind farm is 310 maximum. So what it means that this line is not only meant for this wind farm. Should we have, which is there, it is in the plan, generation sources along the transmission line towards Suswa, then we are able to connect these new plants to this transmission line and you'll be able to evacuate that 1,200 megawatt comfortably into the grid. That would mean if we have this much power into our grid, it would mean definitely the power cost will come down if we are getting these sources from green energies like wind. We have geothermal along the Rift Valley, which is also aimed to be connected here. So the line is going to be a game changer in terms of how much power we can evacuate using this line into the transmission grid through Suswa.
Yeah.
Yes.
Did you think, engineer, in all your time in engineering, did you think that something like this would ever happen in a place like this in Kenya?
No, I never thought about it. Not in this near future that it happened. Yes.
So despite all the hullabaloo, despite all the critics, the naysayers who all said this was a white elephant, was never going to work, well, guess what? It is working. And a good news story for Kenya, no doubt. Why? Well, see the turbine spinning behind me? That means they're on. Transmission station behind me, up, ready, and running. Most importantly, the transmission line. From here in Sirima, 432 kilometers to the national grid in Suswa. This one, tested, retested, and already transmitting electricity all the way to the national grid. By the way, they call this tower number 1. There are 991 of these towers stretching all the way from here in Sirima all the way to Suswa, the national grid. 200 megawatts of electricity so far, with a potential of 310 megawatts. Right now, the entire country produces some 1,800 megawatts. That's going to go up to more than 2,000. Again, a game changer, no doubt, and a good news story for Kenya. Being the perennial pessimists that we are, we decided to follow the path of the transmission line. We wanted to see if the 991 towers Ketraco says it has built, stretching 432 kilometers, had reached its destination. And sure enough, there it was. We didn't count them all, but we can confirm that Turkana wind power has been connected to the national grid, with a potential of adding some 310 megawatts to the already 1,800 megawatts Kenya currently produces.